today we're going to be using REW to measure some microphones. You'll see some photos on your screen now. What I've got is a test speaker. That's one of the Bose Music Monitor speakers, which they're okay for what they are. I'm mostly using it because it's small and convenient. It's a Beyerdynamic MM1 measurement microphone, which I'm going to use first of all. And at the other side, we've got a Behringer UMC 202 HD sound card, which it's fine for what it is and for our purposes today. So when you open REW, you'll get a screen like this, and we're just going to go through the settings and make sure it's all sort of set up and ready to go. So for this particular sound card, you do need the drivers for it if you want to communicate directly with the sound card, which we'd quite like to today. So here's the control panel for that. I'm using this other sound card to talk to you right now, so we need to stay on the 202 to make sure we don't get any weirdness, I suppose. You can calibrate your sound card if you like, that's here, but you only really need that for extreme low or high frequency measurements where the roll off of the sound card itself might be an issue. It's not really a concern for our purposes today. What we are going to be doing is making a calibration file which includes the speaker and the measurement microphone. So all of the microphone measurements that we do today are going to be relative to this measurement mic. So with all that in place, I'm going to click on measure. We'll check levels. Make sure we've got a reasonably healthy level coming in. You don't want the level so high that it might clip, because then your measurement's corrupted, or so low that you're just measuring down in the noise. Somewhere around -20 to -30 is fine, so -28 is okay. I'm going to run the sweeps. And we have a graph. It's a little jaggy, but not too bad. You can see there's quite a lot of fuzz to it. So what I'm going to do is just smooth that out a bit, and we can see sort of the shape of the graph itself. So it's actually a pretty respectable measurement for what it is. It's a 2-inch driver in a small box, and reckons it's getting down to, well, just above 60 hertz-ish, and a fairly flat, well, nicely flat response above 1K. Anyway, what we're going to do is use this to make a calibration curve. So first thing we need to do is drop it so that it sort of wiggles around 0 decibels rather than plus 55. So under controls, we're going to add a offset to the data. I'm picking 55 decibels off, but that's nominal. You could go as high as 60 or as low as 50, I guess, but there you go. I'm just eyeballing it, really. So put that on there, and we've confirmed... Turn it off. We've confirmed it's all hovering somewhere around 0 dB-ish, which is fine. So we're going to export that measurement as text. I'm not really bothered about leaving any notes in it. Oh, I've already got one of those, so we're going to overwrite it. There we go. So, we have a calibration file. We need to set that up in here. There it is. Okay, and close that to save. So now we're going to confirm the calibration has worked by running another measurement, and this one will include the calibration. So what we're hoping for is a nice flat horizontal line. And let's scroll up a bit. Oh, there we go. It's still a little bit jaggy from all the reflections and things in the room, but that's not too bad, especially if we smooth that out. That's pretty ideal as far as speakers go in my book. So what I'm going to do now is I'm going to, here we go, turn phantom power off when I can find the switch. And what we're going to do today is I've got a Sennheiser E906, and that's got a few switches for the mid-high range. So what we're going to do is put the Sennheiser mic onto the stand over the Bose speaker, and we're going to run some sweeps there and find out what the switch does. I think that's a reasonably good demonstration of what we can do with this setup. Of course, once you're playing around with your own microphones, you can pretty much do what you like, really. You know, as long as you can interpret the graphs and things, it's all good, really. So first of all, I've got the switch set to boost at the moment, so let's see what we get there. So we can see already that the sensitivity of the Sennheiser mic is quite a lot lower than the measurement mic. So what I'm going to do is go onto the sound card and turn up the input gain a bit and see what we get. That's just about okay. And there we have a graph. I'll put some smoothing on it again so we've got a general shape of the thing. We can see that boost that's on the switch. That does seem to be coming in the mid-high range there. So what I'm going to do now is find a small implement to, this will do, trusty penknife. So flick the switch down to what should be the flat mode. So we'll give that a go and see how it looks. Okay, another graph. I'm using the keyboard shortcuts for smoothing now, so otherwise there's a lot of clicking around. Okay, and then finally the dip setting. Okay, and we can sort of, if you eyeball it, you can kind of see a change happening, but if you click on the All SPL switch just there, and we'll take off the calibration steps, it gets a bit easier to see that there's quite a difference that's happening in that mid-high range. Yeah, so there's the comparison you can use. You could do that with other microphones, or if you had a bunch of microphones that you needed to test and make sure they're all working correctly, this is a good way of doing it, because you can put them all on the same chart and make sure they're somewhere near each other. Yeah, I think that's it for this particular video, but stay tuned. I'm sure I'll do more in the future. Thanks for watching.